As the tunnels burrowed across the city, they hit an obstacle. They needed to pass right under historic Westminster, including Big Ben. The problem was that the soil here looked like Swiss cheese. There was an underground car park and a huge cavern for a new tube station. The tunnels of the Jubilee line had to squeeze through the middle, right next to Big Ben's shallow and fragile foundations. If during the digging the soft London clay settled more than a few centimeters, Big Ben could have been in trouble. To avert disaster, the diggers called in the man who saved the Leaning Tower of Pisa from collapse, Professor John Burland.
The Big Ben clock tower was constructed in the 1850s, and it's founded on a relatively shallow raft foundation. The problem with tunnelling in the urban area is that however careful you are, you get surface settlement above the tunnel. We did a lot of calculations as to what was an acceptable movement for the clock tower, and we worked out that if the clock face moved by 35 millimetres, that was just sufficient to start cracking. So that was the absolute upper limit. It became clear from very early on, as the tunnels approached the Palace of Westminster, particularly as we were opening up the station tunnels, that the movements were developing and we were going to have to compensate.
Engineer Jem Stansfield shows how the team planned to save Big Ben.
The engineers drilled pipes below Big Ben. And the idea was they would inject grout, a mixture of sand and cement and water, down into these pipes. It would then spread out as a layer below the ground. So the grout was then pumped down through these pipes. It spreads out in there like a layer of icing in a cake. Let's see what we've got there. Okay, now we've got maybe a tiny leak into the northbound tunnel of the Jubilee line, which didn't actually happen. But you see the general idea. The engineers could choose exactly which pipe the grout was going into and out of which hole and how much to correct any movement in the ground and bring the tower to exactly where it should be.
Burland's team punched a network of steel pipes into the ground around the tower. They squirted almost 300 tons of grout into the soil to create a solid layer of concrete. This would make the ground strong enough to drive their tunnels through, or so they hoped. But Burland had never used this technique on such a large scale. To prevent gridlock in the streets, his team worked through the night to squeeze the grout right under Big Ben's feet.
We were nervous as to whether it was going to work or not, and we were watching the measurements that we were making very carefully indeed. And in the clock tower itself, we had something as simple as a plumb line, but it was an automated plumb line, so that the movements were recorded automatically throughout the day and the night. The clock did actually move about 35 millimetres to the north. Our uncertainty at that time was whether it would continue moving once we stopped grouting, or whether it would slow down and stop. And I'm pleased to say that it slowed down and stopped.
Big Ben's reinforced foundations allowed tunnellers to drive the Jubilee line past Westminster. It took just 6 years to extend it all the way to Canary Wharf, linking up the old city with the new.